The universe is an infinite fractal composed essentially of an infinite number of cosmic explosions known as little Big Bangs. If you consult the science textbook published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is no longer the case. Almost 17 years ago, the International Astronomical Union, IU, redefined Pluto's status and excluded it as a planet. Now, the IAU is again debating this issue because NASA has provided clear images of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our solar system to explore the first images of Pluto in our history. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space poses many unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project seeks to discover a world of its own. This monumental project builds on NASA's previous missions, and there is great interest in transcending special discoveries from prehistory. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our solar system, revolutionizing our understanding. Although it is important to ask whether we need to look back for definitive answers about our universe and perhaps reevaluate them, the Pluto question has been the subject of controversy in the field of space exploration. Thanks to the James Webb Telescope and the discoveries that it has provided, we have more and more information to explore our solar system. It seems that the $10 billion investment in NASA has led to a revision of science textbooks to include everything we know about Pluto. This time, it is likely to regain explanatory status. Here's why. Our knowledge about Pluto doesn't end with the controversial IU decision in 2006. In fact, it is the new and renewed capabilities of the James Webb that have provided the pictorial evidence needed to strengthen our theoretic understanding of this putative planet. Although it was believed that previous observations had served to categorize which objects are considered planets and which are not, in reality, the Union had little solid data on which to rely. The images and rules used for this categorization may have been questionable. After the decision in 2006, 2 different scientific positions on the issue emerged. Some believe that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planetary status. Most space explorers have remained undecided on the matter. However, thanks to the fascinating discoveries of the James Webb, the question of Pluto's status remains. The first sharp image of Pluto provided by NASA is rewriting our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been underway for 17 years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was the first time humans were able to get a close look at this space relic and collected the most comprehensive dataset to date about its moons and surface. The New Horizons mission opens up unprecedented possibilities for NASA in its exploration of the Kuiper Belt, a deep region of space. The agency was aware of the need to gain a scientifically sound understanding of the planets that lie between Neptune's orbit and approximately 50 astronomical units from the Sun. The main achievement of the mission was the detailed study of Pluto, now considered a dwarf planet, and its largest satellite, Charon. But it also managed to capture clear images of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission collected data, including the encounter with Pluto and Charon, totaling 6.25 gigabytes. What does this data mean for NASA in relation to the dwarf planet? First, the findings were so groundbreaking that scientists had to develop new data models to better understand Pluto's surface and the atmospheric conditions. It was discovered that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body, but was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was groundbreaking, and its encounter with Pluto took place nearly 80 years ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting closer and closer to a complete understanding of our solar system. It is something you don't hear very often, but with the James Webb Space Telescope, we are bridging the gap between what we know and what we could potentially know. However, there is an issue with missions like New Horizons and any options to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investigating millions to investigate a scientifically important planet may raise questions about the existence of possible life forms elsewhere. Why head to the edges of the solar system? These are challenging questions to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also piqued our interest in further exploration beyond the known confines. In the case of Pluto, its study is fundamental to building a broader scientific understanding of other small planets. Although it lies in a cold, dark region of the universe, the first images of its surface proved groundbreaking enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with valuable information. First, Pluto was found to have a heart. Most geological phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik. Surprisingly, it turns out that Pluto literally follows its heart. A quick glance at NASA's high-resolution images revealed that this heart is white, cold, and nearly frozen, as the left ventricle of Sputnik's heart resembles a vast nitrogen glacier spanning millions of square kilometers. Another notable geologic feature of Pluto's surface is that the axis of its rotation has undergone a significant reorientation, what scientists call a precession process. This was unknown to NASA prior to the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the tidal axis between the moon Charon and Pluto is being influenced by Sputnik Plutinia, the heart of the dwarf planet. This influence has reoriented Pluto so that its basin is more closely aligned with the tidal axis, something that was not previously known. We have always known that this ancient planet is uninhabitable for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the heart of the dwarf planet is a 4 kilometers thick layer of ice, which is very likely contributing to that colossal mass. When combined with tides, this process can cause the reorientation of the planet's rotation axis in search of equilibrium on its own orbit. However, the ice sheet alone is not sufficient to generate a steep reorientation angle or to produce significant heights. As we mentioned before, technologically backed explorations can rewrite our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with an ocean of its own beneath its thick ice sheets and glacier-covered surface. Pluto's interior contains an extensive ocean that also influences the reorientation of its rotation axis. This discovery is extraordinary for several reasons, but above all because it completely changes our understanding of the planet. The highly probable presence of an ocean in Pluto's crust means that we shall have more information about its origin and how it formed. What do you think? Let us know in the comments box. If you liked the video, remember to hit the like button share it so it reaches more people, and subscribe so you don't miss out on more content like this one. Thank you so much for watching the video, and I'll see you in the next one.